Okay, let's chat. Are you ready to chat? So, how'd it go last night? Let's see what that poll said. It said, I think it said you guys liked it a decent amount. 18, 17, number 5. Confusing. It can be easier is okay. So it was decent last night? It was decent? Okay. So which number would you like to look at? Which number?
18.
18. That's a vote for 18. That sounds like a good thing to start with. Okay. 18. So 18 says... 18. Find an expression for the function, that one? Is that the one you're asking about, kids?
Yeah.
Okay. Can you pick up your bag? It's okay. Okay. So number 18. Actually, I'm going to do one thing first before we begin. Please hole punch and do all your stuff when we're not doing lesson time, okay? It'd be fantastic if you could do that. Thank you. So here's the one you wanted. Number 18. Find an expression for the function whose graph consists of the line segment from the point -2 to 2 to the point -1, 0. Okay. Were you able to do that? You have 2 points. Let's call this point A, -2, 2, and that point B, -1, 0. How do you find the equation of the line between 2 points? Yeah, let's do, what'd you say? One at a time. What'd you say? What are you trying to find? Yeah, so it's 0 minus 2 over -1 minus -2. So it's going to be -2 over what? 1, so it's, what's the slope? I really like this form right here. Point slope form. I love that. So you end up with y, which I like. If I had to choose one, I'd choose that point to plug in. So y minus what? If I use this point. Put the calculator down, please, and stop twitching. Y minus what? Is equal to -2 times x minus -2. So you clean it up a little bit. At y minus 2 is equal to -2 times x plus 2. You could clean it up a little bit further. You could leave it like that. That's totally fine. I'm totally okay with that. So you're going from -2 to -1. What type of function are you designing here? What type of function? This one is linear, but altogether, what is it going to be? What type of function is this? Piecewise. Thank you. So we've done one piece. So that first piece is this function. What's the domain of this function? What's the smallest x value it can cover? Nope. -2. The domain here is going to be -2 all the way to -1. So it's from -2 to -1. So the first part of this function, f of x, is going to equal y minus 2 equals -2 times x plus 2 when that's the domain. So we've done the first part. How many other parts are there? How many other parts are there?
There's another part of it's talking about the circle.
The circle. So how many parts, how many pieces are in this piecewise function? 2. We've done the first piece, so we need to do the second piece. The top half of the circle with the center, the origin, and radius 1. The top half of the circle with center, origin, and radius 1. Did you draw this?
Yeah.
So you want the top half of the circle. You want this right here. Does anybody know what the equation of a circle is with radius 1 centered at the origin? Did anybody look it up? Did anybody go outside and maybe look in the textbook that you have at home to find the equation of a circle? No? The equation of a circle with radius 1. Does anybody know what it is? I have a question. Did anybody attempt to look this up in any book or use the internet? You need to start doing that. If you literally taken 10 seconds and typed it into Google or looked it up in your book, you would have found this equation instantaneously. It's not something that we've covered yet, but you can find it. It's there. The equation of a circle with radius 1 centered at the origin is this, right there. X squared plus y squared is 1. Is that a function? No, a circle is not a function. Why isn't it a function? What? It does not pass the vertical line test. Thank you for using a complete sentence. We need to break this into two functions. How do we break this into two functions? We did this before. What do we need to do? Is this written like it is a function? No. Why not? Both variables on one side. Generally, we have, what do we do? What do we need to do? Isolate the y. Thank you. So y squared is equal to 1 minus x squared. So what does y equal? What's missing? Plus or minus. Exactly. Now, you have two functions. You have y equals the square root of 1 minus x squared, and you have y equals negative the square root of 1 minus x squared. One of them is the top, and one of them is the bottom. How do you go about figuring out which one's the top and which one's the bottom? Try some numbers. What's one point that the top arc goes through that the bottom does not?
Y equals 1.
Yeah, it goes through this point, 0, 1. So when x is 0, y better be 1. Which one is it going to be?
Top.
Yeah, it's going to be this one right here. When you plug in 0 for x, what do you get out? When you plug in 0 for x here, what do you get out? Yeah, so this is the top, and this is the bottom. So we know that the second function it wants is the square root of 1 minus x squared, but it just wants the top half of it. What's the domain of the top half of this function? Negative what? Yeah, so we want negative 1 to what? To 1. Now, do you notice that this is not equal? Because when I put this together, it better be a function. What happens if I had also put in an equal sign right there? Would it be a function? No, it would not. You need to decide. One of them is equal, one of them is not.
Oh, so you can be also negative x greater than, or also you can be x.
You could also write it like this. You could also write it like this, if you wanted to. Do you understand? So what does this function look like overall? It's it connects negative 2, 2, and negative 1, 0. So the function you're looking at is this. See the red? There's negative 2, 2, and there's negative 1, 0, and this is the arc that goes through those points, the semicircle. So this would be the final answer for number 18. Yes, that is it. What's the second question you would like to talk about? Let's use hands today, and I'll call on somebody. Let's use hands. Who wants to pick the second question to work on? Yes, Stan.
On page 85.
Number what?
Exercise 5.
Page 85, exercise 5. This one right here. To find the domain and range of each. Is there any one in particular you want to do? I'm not. Oh, just number 5, right?
Yeah.
Oh, good. I just gave you one. Good. Okay. Find the domain and range of the function. How do you go about finding the domain of this function? Somebody raise their hand and I'll call on them. Someone raise their hand. How do you find the domain of a function? What's the general method for finding the domain of a function? What do you start with? What? Yeah, we're going to examine the 4 minus 3x squared, but let's just say I said, here's a function. How do you find the domain of a function? What set do you start with? If there are no limitations on the domain, what's the domain of a function? All real numbers. So you start with all real numbers, and you take away what? Hold on, yeah? Things that x cannot equal. So what are the two ways that you take numbers out of that set? What are the two things you're looking out for? We're not square rooting a negative, and we're not dividing by 0. So you start with all real numbers, and you take away the things that would make a division by 0 or a negative radicand. Is there any division? Radical? Yep. We want an even radical, yep. And you go, yes. So what do we have to make sure of? Can someone state very clearly what we have to make sure of?
1 minus 3x squared is not equal to negative.
So it has to be what?
Negative 0.
Greater than
or
equal to. It can be equal in this case, yes. So how do you find out where this is greater than or equal to 0? Set it equal to 0. Exactly. Equals 0. So 3x squared is equal to 4. So what does x squared equal?
4/3.
4/3, not 3/4. What do you do to both sides?
Square. Square root.
Yeah, and what do you have to put out front? Plus or minus. Thank you, Victor. So that's plus or minus 2 over the square root of 3. You've seen that value before. What is that value actually? You generally don't like radicals in the denominator. It's okay, but if you wanted to get rid of that radical in the denominator, what do you multiply by? Yeah, it's a unit circle trig. This is coming out here, right? What do you multiply by if you want to get rid of that root 3? Root 3 over root 3. You can only multiply by forms of 1. So what do you end up with? 2 root 3 over 3. Is that a pretty common trig value? And there's also plus or minus on this. So you have negative 2 root 3 over 3, and you have positive 2 root 3 over 3. Those are the only places. This is x, and this is the value of 4 minus 3x squared. We know that when you plug in this, you get 0 and you get 0. Are there any other places where this function equals 0? No. So that means that everything here has to be all positive or all negative. Everything over here has to be all positive or all negative, and everything here has to be all positive or all negative. Exactly. Good. Good. So how do you go about? We did this before. So what do you do? What's the easy thing? You pick a number. Pick easy numbers. Let's do the easiest one we can so far. What's easier than that? 0. Use 0. When you plug 0 into this, you get a positive or a negative number. Plug 0 in for x. What do you get? You get 4. So it's positive. Now, you're not quite sure what that equals, right? You don't really know that off the top of your head. But what number is definitely to the right of this? 10 is definitely to the right of it. Pick something that's definitely to the right. What's 4 minus 3 times 10 squared? That's really, really what? Negative. And again, what happens if you plug in negative 10? What's 4 minus 3 times negative 10 squared? Same thing. This is a symmetric. It's a parabola, right? So this is going to be negative. So we want this to be positive or equal to 0. So where is it positive or equal to 0? Yeah, good, Victor. Exactly. So what's the domain of this function? That's the domain. How many of you have practiced or worked with absolute values before? This, I'm just going to give you a preview. We might touch on it a little bit. It's something you should have covered before. This right here is an absolute value statement. Any section of the real number line can be written as an absolute value. What's the middle value between those two numbers? What's exactly in the middle? 0. What's halfway? So you go from negative 2 root 3 to positive 2 root 3 over 3. What's half that distance? So I'm saying you go from this to this. What's the whole distance? 4 root 3 over 3. So what's half the distance? Yeah, and so there's different ways to write this. You can write it like this. X minus 2 root 3 over 3. That has to be less than or equal to 2 root 3 over 3. There's different ways. Has anybody seen something like that before? Have you ever seen an absolute value thing like that before? Okay, then forget it. I'm just giving you a preview of what's to come. You need to be able to do that later in life. It's kind of important. Don't worry about it. I'm just giving you a preview. I saw an opportunity. I went for it. I think I just confused you a little more. Are you okay with this? Don't worry about it, Hanley. Another way. Another way. That's actually not correct, I don't think. You know what? I just messed up. It's easier than that. It's actually just this. I'm sorry. What am I doing? The absolute value of x is less than or equal to 2 root 3 over 3. Absolute value means distance from 0, right? So if we go to the right of 0, it has to be less than 2 root 3 over 3, right? But if we go backwards and we take the absolute value, the distance is still the same. How far can you go? 2 root 3 over 3 from 0. So this right here is another way to write this. I'm sorry, I don't know why I put that subtraction in there. Okay, are there any last ones you want to talk about from the homework? Any brief ones? Anything else? Yes.
17C.
17C. Determine whether f is even, odd, or neither. That one?
P60, 60, no, 86.
So yes. So determine whether f is even, odd, or neither. So f of x is equal to e to the negative x squared. So how do you determine whether something is even or odd? What do you have to do first? Someone raise their hand and tell me, what do you have to do? Raise your hand, I will call on you, and then you'll tell me what the answer is. How do you test to see if something is even, odd, or neither? We did this extensively yesterday. Linos.
Plug in the positive number and make a number.
Nope, not plugging in numbers. What do you plug in? You plug in something. You're right, you plug in something. What do you plug in, though? Plug in negative x. You always start by plugging in negative x. We did that a bunch of times yesterday. So you plug in, if f of negative x is equal to f of x, then what? The function is even. And if f of negative x is equal to, I don't know what that was, f of negative, it's what? Odd. So you start by plugging in, so what is f of negative x? E to the negative x squared. What is negative x times negative x? So you're going to end up with e to the negative x squared, which is what? Which is what? Which is f of x. So f of negative x is equal to f of x, so it's what? So even. This function is even. You could also see it graphically if you wanted to. Y equals second e. E is just a number, everybody. E to the negative x squared. There it is.
E is just a number.
E is a number like pi.
It's not a variable.
No, it is a number. Oh, I'm sorry. E is a number. E is a number.
That's right.
It's just like pi. It's irrational. It goes on forever. Does anybody know where E comes from? Have you ever seen it before? No. Has anybody taken biology? No one's taken biology in this entire class? Did you ever study growth rates of populations? You ever heard the terms carrying capacity? You've seen, I'm sure, if you took biology, you saw a graph that looks something like this. Population starts off with a really small population, it grows, and then the population levels off because there's a carrying capacity of the environment. Natural growth rates, if you find the actual formulas for this, is called a logistic curve right here. Parts of logistic curves, you can't do them without the number E. E is in the natural world all over the place. We're going to talk about it at pretty good length later in this course, but E is just a number. It's E is 2.718 what is it? 1828459045. I think that's pretty good. Let's see how good I am at this. If I wanted E, I just do, ready? Second, there's also E is right there. 2.71828. Oh, 18281828. I'm sorry, there's two of them. 1828459045. You'll get good at that. We'll talk about where it comes from later. That's not important right now. You're not going to get tested on it. But the point is, E is a number, so this is what the graph looks like. So if I just gave you that function, does it look like it's even? It does look like. Can you 100% verify something is even just by looking at the picture? No, because, for example, if you zoomed in, let's say you zoomed in really far, and it looked like this on that side, but over here it was a nice straight line, would that be even? No, but in realistic viewing, does it look even? Yeah, it does look even. Okay. E is an irrational number. Does anybody know what irrational means? Yeah, never-ending decimal doesn't repeat. There's a even simpler way to say it. That's totally correct. What's a rational number?
Doesn't mean that the decimal will end.
He's talking now. Yes? It does end, yes. What's the first 5 letters of rational? What are the first 5 letters? Ratio. Rational numbers can be written as ratios. Irrational numbers can't. You cannot write irrational numbers as a fraction. You can write rational numbers as fractions of integers. Put everything away except a pencil, please. Your homework, hello. When you hear me speak, that means you just stop. Got it? Thank you. First part of your homework is work on corrections. It'd be nice if you could hand in a bunch of them, if not all of them, tomorrow. The second part of your homework is going to be write an original Unit 1 test. Questions on one sheet, answers on another sheet, at least 2 questions for each topic. Something, I mean, you can choose this, something like 1 easy and 1 hard. Make sure, this seems obvious, but I need to state it every time. Make sure the questions have questions in them. Do you understand what I mean? You can't just put down an equation and expect someone to know what to do with it. So, for example, you can't just put down f of x equals some piecewise function and expect them to graph it. You have to say, please graph this function. Be specific. And be neat. Aim for what you think is fair for this test. Any questions about the assignment? Yes.
If I have any,
1, 2, 3. Yes.
if I have any problems, can I email to you tonight or anything?
You can always ask me questions, sure. I'm not going to guarantee that I'll get them, but, I mean, I'll try. I'm not sitting at my computer waiting for student emails in order to reply immediately. I have a little bit more of a life than that.
I'm just saying it is a higher possibility.
It's possible. Yes.
What does the last
Don't try to make the questions too hard. Make it fair. Test questions that you think would be appropriate. So don't make them not impossible. You have to be able to solve them. So you need to also write the answers. But the answers go on a separate sheet. Yeah, Lenos.
Did you print out a syllabus?
It's online. Everything I do. Every last piece of paper I've given you is digital. It's all there. Questions.
So you'll be like, just create it.
Create an original test. Create questions, yeah.
Any
Yeah,
test
the more original the better. You can use books, notes, the net for inspiration. Can use a question you find if it's good. I'm just telling you this now so you'll know you'll be switching these tests up with people in the class and you'll be doing somebody else's test as test preparation. So not only am I going to see it, someone else in the class is going to see it and work on it. So if it's pretty poor, they're going to tell you about it and I'll tell you about it. So make it nice and pretty. Understood? Good. Okay. Get out of here.